Okay, so at this point, I'm getting into what is chapter two in a textbook that I'm no longer particularly using. The author's last name is Malik, Malik like Malik, and the eighth edition of the textbook is corresponding to these chapter numbers that I'm using in case anybody would like to look into that. But the basics of C++, um, okay, these are just some comments about why use C++ instead of other languages. This is okay. So I believe we've talked about this semester, fall 2024, about comments. So this is a comment. Maybe we know comments as being things that we leave on people's Instagram account, social media accounts. But a comment in programming is something that gets ignored by a compiler. And what that means is one example of what that means is if you make a mistake and you type capital C out right here, this is not recognized by the compiler. It's not a legal word or legal instruction, loosely speaking. So if you comment it out, it no longer generates this red squiggly and the program will run. Comments are useful for documentation, saying they're useful for explaining what you are doing with a certain instruction in a program. This comment says initialize an integer type variable to hold the value to. So int a number is equal to 2. So this is a variable named a number, and its value is 2, and it is an integer data type. And that data type is one of the primary focuses of this chapter 2, the basics of C++. Okay, so there are several data types that we will be seeing in these slides. If we're curious about the origin of the term bug, this is a screenshot of a moth or a fly or something that found its way. Insects often like electricity and light, as we are almost certainly aware. So if an insect gets inside of a circuit, then it might get electrocuted and cause a short circuit in the program, and it might cause a program to malfunction. Okay. We can make multi-line comments like this. Multi-line, yeah. So if we want to say we have lots of like a couple of sentences that explain this code below does this and this, and it also does this other thing. Okay. So that's a multi-line comment. We can also do multi-line comments like this, slash, 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 slash. Okay. Tokens are a fairly special word that is used by computer programmers. Expressions is another specialized term, and I will use the term expression pretty often. Okay. This is an arithmetic expression consisting of this 5 plus 2. 5 plus 2 is an arithmetic expression consisting of one operand. So plus is called an operator. Okay, and 5 and 2 are called operands. That's like vocabulary. I don't make vocabulary quizzes usually, but I definitely don't make strict vocabulary quizzes, but I do occasionally ask some vocabulary like questions on quizzes. Okay. So it is my expectation that students read all of this stuff that I'm going through quickly. These are all of the keywords or reserved words in C++. So if you type any of these words, they have special syntax highlighting, like the word namespace is it has a certain color. If you type some gibberish, it is just white in this case, because this is not a keyword, right? This ASDF is not a keyword. But as we will see, if we haven't already, if is a keyword, while is a keyword, double is a keyword, or is a keyword, auto is another keyword, private and public. We'll be talking about these in the data structures class, in the object-oriented programming class. Okay. But one practical takeaway from this is that if you declare what is called an integer type variable, you cannot use keywords to name the variable. So none of these keywords are really examples of things that we would use to name an integer. Maybe new, like old, value, like if you're updating the value of a variable and you say old variable is equal to 31, and then you change the value and you say new is equal to something else, this will generate a compiler error, new. So new expected an identifier. What this means is that you cannot give a variable a name, the same name as a keyword. You can call it KNEW, like I knew someone. I'm just trying to be cute there, but new is not allowed as a name for a variable, okay? You also cannot say something like this. You can't put spaces in between words for variable names, no spaces. So we will also see, in this case, we see expected a semicolon. We can connect the words with an underscore. This is called snake case, because the underscore, this character, looks like maybe a snake that's laying on the ground, except the snake is abnormally straight. We can also use what is called camel case. So camel case. So the first word, there are two words in this variable name, and the first letter of the first word is lowercase, and the first letter of the second word in the variable name is uppercase. So that it looks like the humps of a camel. Camel maybe has two humps. I've never seen a camel in person, but maybe the first hump is small and the second hump that you encounter is larger. And you sit between these two humps in the saddle. Okay. If we're curious about what the keywords are, you can see what they are by going to opening up this external dependencies and going to xkeycheck.h is a header file, which is, it's been a while since I've looked at this guy, but if you open this up, it lists the keywords, auto, boolean, break, case, catch, character, class, etc., etc. If you're curious about that, you can also just look up C++ keywords on the internet. Okay. Data types are hugely important in programming. I've mentioned that part of the reason that I have some preference to teach C++ instead of a more user-friendly language like Python is because C++ and C, it kind of puts it right in your face. It forces you to explicitly declare the data types of variables that you're using. Python as it's more automated, and types absolutely exist in Python, but it's just less in your face is the way I might describe it. All right, so the values a variable can have, this makes sense. If I say int some integer equals, and then I do this does not make, maybe we say hello. This doesn't make any sense. I'm trying to set a number equal to a string of characters. Okay, so integers are allowed to have certain values, and those are integers. It's negative 999, negative 998, negative 997, all the way up through and including 0, and then 1 and 2 and 22 and 9,999. Okay, I just did something here. You might think I should put a comma there instead. This generates an error. If you want to make these large numbers more readable, you can put an apostrophe in. If you're using Visual Studio, this might be problematic in other environments like Xcode or online compilers. But yeah, no comma here. So an apostrophe here, we can do this value, but okay. But there is a maximum value that integers can have because, as I believe I mentioned last time, integers have a certain capacity. They are this this is a computer program and it uses a certain amount of RAM, which you could check by one way to check it is to look at the task manager, open up the task manager, and we see a certain amount of RAM is being used by my machine at the moment, 11 gigabytes out of 16 approximately. Okay, I was just distracted by this Wi-Fi Direct thing. I think that that's a new thing on my machine. Anyways, so if we run this program and I just use this new thing called size of tells you the amount. Let me add some text here. So size of int is size of int. We're going to print this text and then we're going to print a number. So the size of an integer is 4, and that is in bytes. So let me add bytes right there. Technically, the B shouldn't be capitalized, but I often do this because it's bits is conventionally, when it's abbreviated, the bits, it's lowercase, and a byte is uppercase like this. So I just do that to in an attempt to hopefully prevent people from screwing up bits and bytes when they read MB and MBPS, megabytes and megabits per second, network transfer speed. Okay, so yeah, this has a maximum capacity, and that goes back to what we spent some time on the other day, which is binary to decimal conversion. So I'm just bringing that over. So binary to decimal and also decimal to binary. So if we look at this conversion here, this is 4 bits. So this number, this binary number base 2 is equal to 10 in base 10 if you do this conversion here. Okay. So this is 4 bits, and programmers, for reasons that we're not going to get into, defined 8 bits as being equal to 1 byte. So we might ponder the question, what is the maximum value that can be stored with 1 byte of data? So that is in binary, that is this value right here, 111, 1111. Okay, and what is that? We could do the conversion by doing something similar to this process. So 2 cubed, let me just leave it at that. We could do the conversion by, I'm not gonna try to write it out right now because I can't screen share with my tablet, and I don't have a document camera or anything like that. But if I bring up the Windows calculator, for instance, we could do an online conversion. We could look up something on the internet as well, of course. Switch to binary mode. And if you notice, on decimal, the numbers 0 through 9 are available, but on binary, only the numbers 1 through 0 are available. So if I type 111, okay, that's a grouping of 4. If you notice, when I type one more 1, there's going to be a space that gets inserted. Yeah, and it also pads out, this calculator program pads out zeros in front there. So one, and what is this equal to? It is equal to 255. And anybody who's played old school Final Fantasy games may be familiar with this statistic. Like Final Fantasy X, for instance, has a stat cat, a statistics cat, like a character strength maximum value of 255. And it's not a magical, it's kind of a magical number, I suppose. So this is 1 byte. So 1 byte has a maximum decimal value encoding in binary of 255. Okay. And that is in hexadecimal, that is called FF, like people do on Twitch streams, for instance. Okay, so that's 1 byte. And 4 bytes is quite a bit more ones. It is, so this is 8 ones. And if we add, this is going to be maybe painful, but if we add 24 more ones here, we will see let's do that. 1, 2, 3, 4. So that's 1 byte. That's 2 bytes because it's 16 ones, 16 ones, 16 bits. Okay, that's 3 bytes. And that's 4 bytes. Okay. So the maximum value there is 4,294,967,295. Okay. And that corresponds to FFF. So each of these 4 groupings is called 1 byte. Why am I talking about this? Because there is something called int max. Where I forget, it's int underscore max. Okay, and that is 2,147,483 blah blah blah. So what is, so this is, let me print this value, and I'm going to do something a little bit fancy, which is to make commas appear. You may notice if I print some integer right now, it's going to be a bunch of nines it's going to be 9 nines grouped together without any commas, and that's difficult to read. There's a way to make this easier to read. It's a little bit fancy. It involves what I'm typing right now. So a locale, like, are you using a machine in England or France or America or Australia or Korea or something? So different number formats exist in these different countries. I mean, not to go into great detail on that. Cout.imbue. So imbuing cout with certain properties and imbuing it with the properties of this thing called a locale. Let's not worry too much about what lines 29 and 30. Let's not try to make sense of them, but as you notice, there are commas now, so it's easier to read. And you're welcome to use this, of course. And also int max is easier to read now. We printed int max, so the maximum value that an integer can have. So you might wonder why this is 2 billion and not 4 billion. And that has to do with something called unsigned versus signed integers. And so uint max, unsigned integers is, so has this value, uint max, 4,294,967,295. Okay, same value we saw earlier. So didn't want to linger on this too much, except to demonstrate an overflow error. If I print some integer and give it some text here, int max, some integer, it prints this number, but if we add 1 to this, then we cause what is called overflow. And that is overflow. So we get -2,147,000,000, blah, blah, blah. So it's like wrapping around. And we also generated a warning here. It causes overflow. Okay. So this is just something we want to be cautious of because and again, this is part of the reason I like C++ is because it puts this more in our face than Python. Python would kind of sweep in to the rescue and prevent this problem from occurring, perhaps in certain instances. Okay. If we want to see a fairly cute little image of this, I'll bring it up in a minute here. An image of overflow, data overflow. So we might think of this. I'm just fooling around for a second in my directories here in my Windows Explorer is being a little irritating at the moment. But I'm bringing up an image of overflow, integer overflow in this case, and it kind of makes the point nicely. And it's supposed to be a funny image. And there it is. So if we take 8 ones, so a single byte with max capacity, and we add 1 to it, 1 plus 1 turns out to be 0 in binary. We carry the 1, 1 plus 1 is 1 plus 1 plus 0 is 0. We carry the 1, and so on. And then eventually we carry a 1 here, and it pops out, it explodes out of the computer and makes this guy alarmed. Okay. So I'll stop at that point for this video, just doing some warm up for class.